Hello everyone, welcome back in this channel. So in this tutorial we're going to discuss more about multiplication of matrices. So we'll start with an introduction. So the main rule is that for it to be possible to multiply two matrices, for example if you have two matrices, maybe matrix A and matrix B, the number of columns in the first matrix should be equal to the number of rows in the second matrix. So basically this means that the number of columns in the first matrix should be equal to the number of rows in the second matrix. So let us do it practically. For example, if you have this matrix, we have matrix A, which has these elements. It has 3, 1, 2, 4. And then there is a 7, 4. So you're going to enclose it in brackets. And then you have another matrix B, which has these elements. For example, it has 8, 0, 5, 4, and then it has 3, 2, 1, 1. So you're going to enclose it in brackets. So we have these two matrices here. So the first matrix A, it is a 3 by 2 matrix. It is a 3 by 2 matrix. This is because it has 3 rows. It has 3 rows. For example, this is the first row, the second row, and the third row. And it has 2 columns. This is the first column, and this is the second column. So making it to be a 3 by 2 matrix. So a matrix B here, it is a 2 by 4 matrix. It is a 2 by 4 matrix, meaning that it has 2 rows and 4 columns. So this is what we mean. It has 2. This is the first row, and this is the second row, and it has 4 columns. This is the first column, the second column, the third column, and the fourth column, making it to be a 2 by 4 matrix. So back to our rule, we have said that for it to be possible to multiply two matrices, the number of columns in the first matrix. So the number of columns here, we have 2 columns. These are 2 columns. And the number of rows in the second matrix, we have 2 rows. So this makes it automatically compactable to undergo multiplication. This is because it has an equal number of columns and an equal number of rows. So the next thing that you're supposed to learn here in the multiplication of matrices, when you multiply two matrices, for example, you have this matrix. This is a first matrix. So if you multiply these two matrices with another matrix, for example, BC matrix. So when you multiply these two matrices, so this one represents the number of columns, and this one represents the number of rows, whereby we have said for them to be for them to undergo multiplication, they must be equal. So when we multiply these two matrices, the resultant matrix should be an AC matrix. So this is what we mean mathematically. For example, if you have a 3 by 2 matrix, we have a 3 by 2 matrix and another matrix which is a 2 by 4 matrix. As you can see here, we have two columns and 2 rows. Basically, this means that these two matrices can undergo multiplication, meaning because it has an equal number of columns and an equal number of rows. So when you multiply these two matrices, the resultant matrix should be a 3 by 4 matrix. So the resultant matrix should be a 3 by 4 matrix. This should be the resultant matrix. So we are going to prove this mathematically by multiplying two examples. So we are going to prove it mathematically. So you are going to have two matrices which you are going to multiply. So let us do it practically. For example, you have matrix A here, which is 3, 1, and 2, 4. Then we have 7, 4. So we are going to enclose it in brackets. These are matrix A. And then we have a matrix B which you are going to multiply. Matrix B, which the elements are 8, 0. They are 8, 0, 5, 4. And we have 3, 2, and 1, 1. So before we begin multiplying, we must first of all confirm that these two matrices can be multiplied. So this one here, it is a 3 by 2 matrix, basically because it has 3 rows and 2 columns. And this one, it is a 2 by 4 matrix, meaning that it has 2 rows and 4 columns. So we can see here, these are the we have 2 columns and we have 2 rows. So these are equal. The number of columns and the number of rows in the second matrix, they are equal. So this means that these matrices can undergo multiplication. So, and we have something in our mind that the resultant matrix must be a 3 by 4 matrix. So when we multiply these two matrices, our resultant matrix must be a 3 by 4 matrix. This will be our resultant. Matrix. It must be a 3 by 4 matrix. So let us now multiply and see if we are, and prove that we'll get a 3 by 4 matrix. So we are going to multiply this matrix. So our first matrix was 3, 1, which is matrix A, then 2, 4, and then 7, 4, whereby you're going to enclose them in brackets. So you're going to multiply with the second matrix, which is 8, 0, 5, 4, and 3, 2, 1, 1. So when you're multiplying these two matrices, you start with the rows in the first matrix, then multiply with the elements of columns in the second matrix. So this is what we mean. We multiply rows in the first matrix with the columns in the second matrix. So we are going to do it practically. So let us do it practically. For example, here we are going to start with 3 multiplied by 8, then 1 multiplied by 3, meaning that you are multiplying the elements in the rows in the first matrix with the elements in the columns in the second matrix. So we are going to do it practically now. So you are going to multiply 3 multiplied by 8. Then you are going to add 1 multiplied by 3. As you can see, we have multiplied the elements in the rows in the first matrix with the elements in the columns in the second matrix. So we still proceed. So you're going to multiply. You still proceed with 3. These are 3 multiplied by 0. That is in the second matrix. Multiply by 0. Then you'll add 1 multiplied by 2. Then we still proceed. We have 3 multiplied by 5. You add 1 multiplied by 1. So lastly, we have 3. You multiply by 4. Then you add 1 multiplied by 1. So as you can see here, we are multiplying the elements in the rows in the first columns with the elements in the columns in the second matrix. So let us proceed with the next row in the first matrix, which is 2. So you are going to take 2 multiplied by 8, then plus 1. It is, you are going to take 1 multiplied by 3. So sorry, we are going to take 2. So in the second row, so it is 2 multiplied by 8. Then you'll take 4. Multiplied by 3. As you can see, these are second row in the first matrix. And then you're going to multiply with the columns in the second matrix. So we proceed on. We are going to take 2 multiplied by 0. As you can see, this is 2. Take this 2 multiplied by 0 here. Then you're going to take 4. You're going to take 4. So you're going to add. You're going to take 4 multiplied by 2. As you can see, this is 4. multiplied by 2. So basically we have multiplied the elements in the column, in the row, the second row now here in the first matrix, with the elements in the second column, in the second matrix. So we still proceed. We are going now to take 2. It is 2 multiplied by 5. Then you'll add 4 multiplied by 1. 4 multiplied by 1. Then you still proceed. You are going to take 2. You are going to take 2 multiplied by 4. This 4 here. And then you will take 4 multiplied by 1. You add 4 multiplied by 1. So we now move to the third row in the first column, in the first matrix, sorry. Then you multiply with the elements in the columns in the second matrix. So we are going to take now 7 multiplied by 8. Then you'll add 4 multiplied by 3. 4 multiplied by 3. Still proceed. You're going to take now 7 multiplied by 0 plus 4 multiplied by 2. So what you are doing is that you are multiplying the elements in the rows in the first columns with the elements in the columns in the second matrix. So we'll take 7 multiplied by 5, and then you'll add 4 multiplied by 1. And then you're going to take 7 again, 7 multiplied by 4. This is 4. So you are taking this element in this column, multiplying it with the elements in the first row, in this row, that is 7, 4. Then we are going to multiply with the elements in this column in the second matrix. So it is 7 times 4. Then you're going to add 4 multiplied by 1. So you're going to enclose this one in a bracket. So we are now going to multiply them directly now. So we have 3 times 8. We have 3 times 8, which is equivalent to 24. So 24 plus 3, you will get that it is 27. So let us proceed. We have this one here, 3 times 0, that is 0. Then you'll add 1 times 2. 1 times 2, which is equivalent to 2. So here we'll have 2. Then you proceed to this one. We have 3 times 5. 3 times 5, which is 15. Then 1 times 1, it is 1. So you are going to take 15 plus 1. 15 plus 1 is 16. So we move to this one. This is 3 times 4. 3 times 4, it will give you 12. Then 12 plus 1 is 13. Then let us move here. 2 times 8. 2 times 8 is a 16. Then 4 times 3 is 12. So you are going to take 12 plus, we are going to take 16 plus 12. So 16 plus 12 will give you a 28. Then we proceed on. We are going to take now this one, which is 2 times 0, which is 0. Then 4 times 2 is 8. So 0 plus 8 is 8. So we proceed on to this one. 2 times 5 is 10. Then 4 times 1 is 4. So 10 plus 4 give you 14. Then we still proceed to the other one. 2 times 4 is 8. Then 8. Then 4 times 1 is 4. So it is 8 plus 4, which is going to give you 12. So we proceed to the last one here. So 7 times 8. 7 times 8 is 56. Then 4 times 3 is 12. So you are going to take 56 plus 12, which is going to give you a 68. Then you proceed. 7 times 0 definitely give you a 0. Then 4 times 2 is an 8. So 0 plus 8 will give you an 8. Then we proceed on to 7 times 5 is 35 plus 4 times 1. 4 times 1 is 4. So 35 plus 4 will give you a 39. 39. Then the last one here, we have 7 times 4. 7 times 4 is 28. So 28, then 4 times 1 is 4. So 28 plus 4, definitely it will give you a 32. So this now is our resultant matrix. As you can see here now, we have a 3. Our resultant matrix, we have a 3 by 4 matrix. It is a 3 by 4 matrix, meaning that it has 3 rows. It has 3 rows and 4 columns. So let us see now. So this is what we said earlier before we started multiplying. We said that our resultant matrix should be a 3 by 4 matrix. So we have proven that it is true. Since our answer here, it is a 3 by 4 matrix, meaning that this matrix has 3 rows and 4 columns. So thank you very much for watching this tutorial. Basically, that was multiplication of matrices. So if you are new in this channel, remember to subscribe, comment, share, like, and also hit on the notification bell so that you'll always be notified on our new uploads. Thank you.